I want to take you on a journey from the world around us to the world above us. So, this is going to be a talk on astrophysics, on the world beyond Earth. Ever since humankind started exploring the world around us, we have been fascinated by this nature of time. Does time have a beginning? Was there ever a time when there was no time? Will time ever cease to exist? Is time discrete or is it continuous? Is it possible to go forwards in time, backwards in time? These are some big questions that the human mind has been trying to grapple with for centuries, if not millennia. So, time remains a very mysterious entity. At the same time, it remains a very fundamental entity, a very fundamental building block of our universe. If there is one thing that we know about time, then that is that there is a directionality to time. We always find that time flows in one direction. There was a yesterday, there is today, and we know that there will be a tomorrow. So this is called the arrow of time, and the arrow of time has its underpinnings in laws of thermodynamics. Now, how wonderful it would be if we can move through this timeline at our own fancy, at our own desire. It will be great if we can go back into the past, and it will be equally interesting if we can go into the future. So the question is whether time travel is possible or not. The answer is yes, time travel is possible, but not maybe in the sense that we imagine time travel to be, or not maybe in the sense that science fiction movies portray it to be. But what I'm going to try and tell you right now is that all of us sitting here and everybody, we can all travel in time at zero cost. It doesn't cost anything to do time travel. And there's only one caveat in this, there's only one catch in this, which is that we can travel backwards in time, we can access the past in a very real way. I'm not talking metaphorically, I'm not talking poetically. In a very real sense, we can actually travel backwards in time, but maybe not travel forwards in time. Now, all of you, since most of you are engineering students, you know that light has a finite speed. Light travels at the speed of 300,000 kilometers in 1 second. Okay, that is the speed of light in vacuum. Just to put that number in perspective, what that means is that a light particle can go around the Earth 7 times in 1 second. That is the speed with which light travels. So light is the fastest object in this entire universe. But the objects that we see in the night sky, the stars, the twinkling stars that we see, they are at enormously large distances from us. For example, the nearest star to us, other than the sun, the nearest star that we see in the night sky is a star system called Alpha Centauri AB, and another third star called Proxima Centauri. So these are the 3 stars which are closest to us in the universe. But this word closest has a very interesting definition in astronomy. These stars, Alpha Centauri, AB and Proxima Centauri, they are at a distance of approximately 4 light years from us. Now what that means is that traveling at a speed of 300,000 kilometers in 1 second, light takes 4 years to reach us from Alpha Centauri, Proxima Centauri system. So in other words, if you go out tonight and look at the sky, and if you look at Alpha Centauri, Proxima Centauri, the light that is entering your eye started its journey 4 years ago. So you would be seeing how these stars were, not as they are now, but how they were 4 years ago. The sun is 8 light minutes away. Sun is very close to us, but it is still 8 light minutes away. So what that means is if you step out now and look at the sun, the light that reaches your retina started off its journey 8 minutes ago from the sun. So if the sun were to stop burning right now, we would continue to see it in the sky for 8 more minutes. Sun, Alpha Centauri, Proxima Centauri, these are all stars that are very close to us. We know that our solar system is part of a large collection of 200 billion stars that we call as the Milky Way. If we could, hypothetically speaking, if we could journey at speeds, very large speeds, and if we could get out of our galaxy, we will find that all these 200 billion stars, of which our own sun is a part, they all form a huge disk-like structure which we refer to as the Milky Way, and we are embedded inside the Milky Way. We are sitting inside the Milky Way. This Milky Way is a really large structure. It's about 100,000 light years across from one end to another. Sitting inside the Milky Way, if you take a picture of the night sky, every star that we see in the sky, night sky, with our unaided eye, they are all stars that belong to our own galaxy, the Milky Way. And each one of them is at 100 or 1,000 or tens of thousands of light years from us. In other words, what that means is when you stare up into the night sky, you are actually taking a trip back in time. Every star that you see in the night sky is not how those stars are right now, but how those stars were when the light particles started out their journey. If you are looking at a star that is 100 light years away, then the light that is entering your eye started off its journey even before you were born, even before your parents were born, probably when your grandparents were meeting and trying to create your parents. So that is when those photons started out their journey, and now we receive those photons here on Earth. So the night sky is a time machine, and the further back in space we look, the further back in time we are looking. And this is the time machine that I have been talking about. Now, our own Milky Way is not the farthest that we can see. We can see things even beyond the Milky Way. Here is a photograph of the night sky taken by a scientist in Vikram Sarabhai Space Center. He is also a former student at IISc where I teach. His name is Fakhar Haseez. So he took this with a DSLR camera mounted on a tripod, a long exposure photograph. So if you look at this photograph, you see lots of dots. All those dots are stars within our own galaxy, but down at the bottom, you can see a fuzzy extended object. That is the Andromeda Galaxy. Andromeda Galaxy is one of the largest galaxies outside of the Milky Way closest to us. If you use a bigger telescope, this picture was taken with just a DSLR camera, but if you take a big telescope and take a picture of Andromeda, you would see something like this. So this Andromeda Galaxy in itself is an island universe containing billions of stars in it. But in the sky, it appears as a very faint blob because the distance to Andromeda is 2.5 billion light years. This is the galaxy that is closest to us. Okay, the distance is 2.5 billion light years. So when we look at Andromeda Galaxy, suppose let's say we go out tonight. I know that TKM has an astronomy club. So suppose the astronomy club people take you out to look at the night sky, look at Andromeda Galaxy through a small telescope, and the light that is entering your eye started off its journey 2.5 billion years ago. Those light particles started off on their journey. They travel through the immensity of space. They travel through the darkness of space for millions of years. In that time period, human species evolved from a hunter-gatherers. We became pastoral societies. Kingdoms and empires rose. Many interesting things happened. Finally, they entered Milky Way galaxy, and of all the places that these photons could have gone, they came straight to the solar system. There also nothing stopped their journey. It continued, and finally it entered the Earth. It passed through the Earth's atmosphere. There also any atom or molecule in the Earth's atmosphere could have absorbed or scattered these photons, but it did not happen. These photons went through the Earth's atmosphere, and finally when you look through the telescope, those photons enter your eye. Your retina absorbs those photons, and there the journey of 2.5 billion years ends. So in a way, the universe is trying to reach out to us. It is trying to communicate with us, and whether it's up to us or whether we want to listen to it or not. So this is a fantastic time machine. Andromeda Galaxy is as faint as we can see with our naked eye. But there are ways to enhance our vision, and that is done with the help of telescopes. These are two stunning photographs of the Himalayan Chandra telescope. This is a telescope that is operated by the Indian Institute of Astrophysics in Bangalore. The telescope is located in the Leh region of Ladakh near a mountain called Mount Saraswati, very close to the Chinese border, about 4,500 meters above sea level. And these telescopes are like our third eye. It allows us to see farther, deeper, and fainter into the universe. And with these telescopes, we can take spectacular photographs like this. So this is a picture of a cluster of galaxies. Like human beings, galaxies also like to be in groups and clusters. So in this, every extended object that you see here is a galaxy with billions of stars in it, very much like the Milky Way. And we can have telescopes on ground, on Earth, but we can also have telescopes in space. So this is the famous Hubble Space Telescope. It is in what is known as the low Earth orbit, 600 kilometers above sea level. Hubble is virtually above the densest part of Earth's atmosphere, and sitting in space for over 30 years, Hubble Space Telescope has been providing us with spectacular images of our universe. So here are some beautiful photographs of galaxies taken by Hubble. Each of them is a way for us to look back into the past history of the universe, because the light that reaches us from these galaxies have been traveling for millions of years. So we are seeing how these galaxies were millions of years ago, not how they are right now. Soon after Hubble Space Telescope was launched, the people who were controlling the space observatory, they decided to do a very interesting experiment. I'll quickly talk about this experiment. And this experiment showed how vast the universe we live in. So what they did is, they selected a small patch of the sky of the size of a 1 rupee coin held at arm's length. So if you take a 1 rupee coin and hold it at arm's length, it will block a certain region of the sky. So they selected a small patch of the sky of that size. When you look at it from ground, you don't see anything there. Even if you use the biggest telescopes on ground, you don't see anything there. It's a black patch of sky. And they asked Hubble Space Telescope to look at this particular region. So this red dot is that particular region. And for 10 consecutive days, the cameras of Hubble Space Telescope kept looking at this tiny patch of the sky. So it was an exposure that lasted for 10 days. And at the end of 10 days, the data was sent back to Earth, and this is what Hubble saw. It's called the Hubble Deep Field. Every object that you see in this picture is a galaxy with billions of stars in it. Every single one of them is a galaxy like our own Milky Way with billions of stars in it. The reason why they appear as small is because of the enormous distances that separate us from these galaxies. So we are actually looking through the past history of the universe. The galaxies that are nearer to us, we are looking at the more recent history, and the galaxies that are further away from us, we are looking at the past history of our universe. So telescopes like the Hubble Space Telescope is acting like a time machine. It is helping us to put together the growth phases of galaxies in our universe. For example, if you look at any galaxy in the nearby universe, it will look like this, like a whirlpool, okay, like a spiral galaxy. But if you look further and further back in space, you are also looking backwards in time, and you will see how galaxies formed or how they looked when the universe was much younger. So with the help of these powerful telescopes like Hubble, and now JWST is also going up, and with all the ground-based observatories, we have been able to look very close to the initial few billion years after the origin of the universe, after the Big Bang. Many of you know that Big Bang corresponds to the origin of our universe. So this is essentially what I wanted to convey to you. The night sky is a time machine. Every time we look up into the night sky, we are actually taking a trip back in time. And the night sky is accessible for everyone. It is not just accessible for any privileged group. So whenever you look up into the night sky, you have to imagine that you are actually peering into the past history of our universe. I don't have any particular summary slide to show you, but I want you to show 3 more pictures and leave you with the profound message that those pictures convey. So along with trying to look into the far distant universe, one of the things that scientists have been trying to do is also to look back at ourselves and try and understand where we belong in the vast canvas of the cosmos. So Here is a picture of Earth taken by Apollo astronauts. Earth looks like a blue marble when seen from the distance of Moon. Okay. This is not the farthest picture of Earth that we have taken. Here is another photograph, a real photograph, taken by a spacecraft called Cassini. Cassini was launched by the US Space Agency to study the outer planet Saturn and its moons. So what you see over here are the rings of Saturn. Here the light from Saturn is blocked. But if you look down here, there is one pixel that is very bright. That is Earth seen from the distance of Saturn by Cassini, from a distance of 1 billion kilometers. That is Earth. Now, even this is not the farthest photograph that we have taken of Earth. That credit goes to Voyager, a spacecraft called Voyager, which was launched in the late 1970s. On February 14th, Valentine's Day 1990, Voyager spacecraft took a picture of the Earth from the fringes of the solar system, from the far outskirts of the solar system, even beyond the orbit of Pluto. That picture is this. This red band of light that you see, that is scattered sunlight from the camera optics, but right at the center of it you see one bright pixel. That is Earth seen from a distance of 6 billion kilometers. So think about this, a picture that conveys a lot of ideas. Think about this for a moment. This is a selfie that includes all of us. This is a global selfie. All the 7 billion people who live on this planet, all the billions of living species, every famous superstar, every powerful politician, every saint and sinner, every father and mother, every child, all our hopes and ambitions, all the people who lived before us, all those who are living right now, and all those who are going to live after us, they are all confined to this one pixel, a mote of dust suspended in sunbeam. So this is a very profound image, and images like this remind us that who we are and the place that we occupy in this vast universe. So you don't need any particular source of entertainment in your daily life. If ever you feel bored, all you have to do is go out and look at the night sky. The night sky has enough in it to keep you entertained for the rest of your life, to keep you wondered, to give you a sense of curiosity.